What's really important to be aware of with this, though, is when not to use this rule. So let's say we've got this. We've got 3z squared minus 4z. This z, I mean, it's just a variable, same as x. It doesn't really matter. But what you notice here is that these variables here, we should be taking the derivative of that. What we notice here is that these variables are separated by subtraction. So because they're not multiplied together, we're not going to use the product rule. We're just going to do them separately. So the derivative of 3z squared, bring down the exponent, subtract 1 from the exponent, and then that 4 is along for the ride. The derivative of z to the first power, z to the 0 power, or 1, so we're just going to have 6z minus 4. We absolutely can do everything that we've done so far with different variables. We just have to make sure that instead of writing d over dx, we do d over dz, or whatever variable we're using. The thing to notice here is that if it's not multiplied together, there's no reason to use the product rule. Let's say, though, that we've got a slightly different situation. I want to take the derivative of, let's say it's 3t to the 5th cosine of t minus 2t to the 9th. One of the things that we should notice here is that we do have two functions that are multiplied together right here. 3t to the 5th times the cosine of t. And so we do have a spot where we're going to need to use our product rule. However, we also have this over here that's separated by subtraction. So we're going to treat this part using the product rule. But this is just off to the side. We're just going to do it separately like we have in the past. Another way that we can write this if we wanted to is we could say that this is the same as the derivative of 3t to the 5th cosine t minus the derivative of 2t to the 9th. Separate problems. This is the only one that we're going to use the product rule for. So let's go ahead and do that. We're going to do the derivative of 3t to the 5th, and then just plain old cosine t. And then we've got to use the product rule, so that's going to be plus 3t to the 5th times the derivative of cosine t. And notice that this entire thing right here this is all just this piece, where we started off with one term, no addition or subtraction. Now all of a sudden we have two separate terms. This part here still needs to come along for the ride, though. We're still going to take the derivative of 2t to the 9th. You might ask me why I still have this here, why I haven't just done this step. That's because I'm going to avoid taking any derivatives until I'm ready to take all my derivatives, just so I don't lose my pieces. So at this point I can take the derivative here, 3, bring down the exponent, 5t to the 4th, cosine t, plus 3t to the 5th stays the same. The derivative of cosine is negative sine of t. And then when I take this derivative, that 2 is along for the ride, bring down the 9, subtract 1 from the exponent. Now, 15t to the 4th cosine t plus 3t to the 5th. This negative sine t we see is just negative 1 times the sine of t. So that negative can come along in front. minus 18 t to the 8th. So this is where the problems start getting a little bit messier. You want to make absolutely sure that you're really careful to keep each piece separate in terms of like this versus this, and that you're very, very careful with showing your work just because little things get lost. There are a ton of negatives that can get lost, there are a ton of numbers that can get lost. These aren't things that you're really able to do in your head and get them 100% right. Watch out on the AP test because they're going to look for the little tiny things that are really easy to lose. Should be easy to lose. Let's do a check for understanding on this. I want you to take the derivative 2x times the cosine of x plus 2 sine x. Try that one on your own. Pause the video now. So the first thing for me to realize is that this is really two separate problems. One is that I want to take the derivative of this 2x times cosine x, and the other is that I want to take the derivative of 2 sine x. These are the ones where we have two x's and they're multiplied together. So this is where I've got my f and my g. This one, I'm not going to need to use that rule. So, f prime g plus fg prime, the derivative of 2x cosine x is along for the ride, plus f times the derivative of g. Now make sure you don't lose this. Also along for the ride. Taking the derivative of 2x, that's just going to give me 2. Cosine of x is along for the ride. 2x is along for the ride. The derivative of cosine is negative sine. And then here this 2 is along for the ride. The derivative of sine is cosine. Be very careful about what you're taking the derivative of and what you're not. Here we're not taking the derivative, here we are. Okay, now we can write this as 2 cosine x. This negative can come in front. Notice we have two cosine x's, so just like if this were any other variable, we can just make that into 4 cosine x minus 2x sine x.